All right, where we left off with the Valentines formula, and I was kind of joking, but kind of half being serious that you should write a letter to your significant other or poem during Valentine's Day, and that you should write that you're cosine squared and they're sine squared, and together you guys are one. And I was kind of being serious, but kind of joking as well, that if they don't get it, you should definitely upgrade because you need someone that's on your level. You need someone that's going to push you, and the other way around, right? Like you push them, they push you. You want to get better all the time. So give them a chance, I guess, at the moment and say, look, well, let me teach you, and then you teach them. And if they don't get it the second time around, then just drop them. No, I'm kidding, guys, but be nice. Teach it to your parents. Tell one of your dad to get like cosine squared, and then tell your mom to get sine squared. A ring, you know? Oh, okay. No, I just think it's cute. Like if your mom would have cosine squared and your dad would have sine squared, like wouldn't it be cool? Like engraved, yeah. Together you guys are one. All right, so here we go, guys. Cosine squared plus sine squared equals 1. It's not called the Valentines formula. If you talk to your professor, you're going to call that the Pythagorean trig identity. And if you call it the Pythagorean trig identity, he or she will automatically know what you're talking about. That's what this is called. And these are ways that you can substitute. Cool? All these equations are the same one from the Pythagorean trig identities. You just divide everything by cosine squared, or take the Valentine's formula and divide it by sine squared, and you'll get those expressions. Okay, what is an even function? What is an odd function? In Algebra 2, I think we talked about even and odd, right? And also in Precal as well, remember? Okay, so an even function is symmetric about not the origin, that's odd, the y-axis. So an example of an even function is like y equals x squared. So what's an even function? Well, the cosine curve looks like this. So cosine curve is an even function. What else is an even function? Well, the reciprocal of cosine. What's the reciprocal of cosine? Secant. An odd function is symmetric about the origin, which means like flip, like y equals x cubed. So an odd function, and I'll change my colors to indicate odd. So what is an odd function? Flip, something like this. That's an odd function. See if you reflect across the x-axis, whatever is in quadrant 1 is in quadrant 4. And then if you flip it again on the y-axis, what's in quadrant 4 will be in quadrant 3, and those curves will overlap. Does that make sense, guys? So how does the sine curve look like? The sine curve looks like this. And because the sine curve looks like that, the sine curve has to be a odd function. So this in blue is odd, this in red is even. What else is an odd function? Well, that means y equals sine x is odd. Not odd as in weird, but odd as in, it's odd. What else is odd? The reciprocal of sine. What's the reciprocal of sine? So cosecant is odd. What else is odd? Tan is odd as well. And then the reciprocal of tan is also odd. All these are odd. Cool or not cool? Cool. All right, let's keep going. What about when sine, cosine, tangent, blah, blah, blah are squared and have a negative argument? So before we talk about, okay, real quick, guys, how do you say sine is squared? You put the square immediately after the n. If you do this, don't write this down, or not this part. If you do that, are those the same? No. If you do that, the theta is being squared, not the sine. So these are not the same. Do we understand? Okay. So what it means is this. What happens when you square a negative argument and the same magnitude but a positive argument? So let's see. Do you guys remember what sine of negative pi over 6 is? Do you guys remember what sine of pi over 6 is? I don't know, Travis. Yeah, which one's 1/2? The pi over 6 one, right? Sine pi over 6. Sine of pi over 6 is in quadrant 1. Sine is the y value. So 1/2, and I'm squaring that, and you get 1/4. Sine of negative pi over 6, negative pi over 6 is in quadrant 4. Remember, it's a y value. The y value in quadrant 4 is, starts with an n. The y value in quadrant 4 is negative. So sine of negative pi over 6 has to be a negative half. But notice when you square it, what's negative times a negative? So what am I trying to say? Chavez, what are you trying to say? I'm just trying to take notes. I'm not, it's Friday, I'm tired. Just tell me what you're trying to say. What I'm trying to say is when you square any of them, sine, cosine, tangent, it doesn't matter if it's a negative argument on the inside, it's always going to be a positive on the outside. So finally, here's what I'm trying to say. Sine of negative theta, as long as it's squared, is the same thing as saying sine squared of theta. For all of them, not just sine. Well, cosine doesn't matter because cosine was even. Cosine squared of negative theta is going to be the same as cosine squared of theta. Notice that I just took out the negative. Chavez, I don't understand. Look, there's a negative there. My output was 1/4. No negative on this one. And the output was still 1/4. See? We still okay, guys? Garcia, you still all right? Okay. But we're good now, though, right? Okay. You guys okay? Yeah. Yeah, all I'm saying is, I don't care. If you see a negative and it's being squared, you can rewrite it in terms of a positive argument. Negative times the negative is positive, so just, all right. What identities should you know cold? You should definitely know cosine squared theta plus sine squared theta equals what? 1. You should definitely know that, no matter what. And to a certain extent, oh man, I don't know if I should, I'm going to mention it. To a certain extent, do you know that sine and cosine are out of phase by 90 degrees? Did I mention it in the next one? Okay, I'm not going to say that then. What else should you know cold? Cosine is even. Sine is odd. And then from there, you can get the other rules. So no big deal from that. Are we still okay? All right, let's go to the next page. Oh, what's up? Yeah, S. Oh, you want some of this? Here. That way you can follow along. Oh, it's the same for tangents. Tangent squared. What do you mean? Well, tan is odd, but for sure cosine and sine, like you gotta know it. Boom, boom. Okay. Cosine and sine differ by pi over 2, by 90 degrees. So check it out. I'm going to go to Desmos, and I'm going to type in y equals cosine x, and I'm going to type in y equals sine x. And no one's confused. Everyone's okay. Are we still okay? All right. The difference between the peak of the red one is cosine, the blue one is sine. The difference between both peaks, they both differ by 90 degrees. And watch, you're going to see right now, guys. So look, there's my cosine graph right there. What's 90 degrees in radians? So check it out. Pi over 2. And don't worry, I'm going to move the little bit and put a minus. And look at that. Let me turn off the blue one. So there's my cosine graph, and now I'm going to turn on the blue one. Look at that. Does it look exactly like it overlaps? Yeah, so sine of pi over 2 minus x is the same as cosine. What about the other way around? So I'm going to clear this one out, guys. So look at this. I'm going to do the same thing. So we have pi over 2 here. Move, minus. And look at that, guys. Let me turn off the red. There's my sine curve. And as soon as I turn it back on, look at that. Overlaps perfectly. Cool. No, it's not magic. The reason why it overlaps perfectly is because they're both out of phase by 90 degrees. Cool? So what am I trying to say? Chavez, just tell me what you want me to write. Well, I mean, there's more, but I want you to know this, like know it. So what am I trying to say? That cosine x is, if you want to write it in terms of sine, you can write sine pi over 2 minus x. Or you can say sine x is the same thing as cosine pi over 2 minus x. You can toggle them back and forth. You just got to make sure you put that pi over 2 minus x deal. Are we okay with that? All right, and then one last thing. I feel like an infomercial. They're like, one last thing. If I add 2 pi, guys, you're still back in the same location, and that's the same thing as sine x. Obviously, you lost me. I don't know what you're just saying. Think of the unit circle. If you're at the rate pi over 6, and you do 1 revolution, isn't 1 revolution 2 pi? Ain't I in the same location at the same ray if I go pi over 6 plus 2 pi? Yeah, that's all I'm saying, guys. So cosine of x plus 2 pi is the same thing as just saying cosine x. Cool or not cool? And then for tan and cotangent, you can say the same thing. It would be a true statement, x plus 2 pi. But remember that the period of tan is pi. So this is also true. And that's the same thing for cotangent as well. Are we okay? Okay, now we can have some real fun. I know talking about identities is not like the best thing, but now we can have real fun now. All right, check it out. Here's what you're going to see today in your online quiz. So it says, which of the following is equivalent? Sine negative theta, cosine negative theta. Here's how you should be thinking in your head. You look at the answer choices and notice, this is called the argument inside the parenthesis. Notice that none of the arguments, besides one of them, none of the arguments are negative besides one. So maybe, well, maybe, but you never know. Sometimes it's the answer. So maybe they want the argument to be positive. What did we say sine was? Was sine even or odd? Sine is odd. Because sine is odd, put the negative on the outside, sine theta. There it is. That's a property that we use. Over cosine is what? Even. So cosine negative theta is the same thing as cosine theta. Now I look. That answer is not in there, but check it out. Sine over cosine. Sine over cosine is just what? Tan. So there it is. Look for a negative tan theta. There it is. Bam. Yes. Happy face right next to it. How do we feel? Awesome. Yeah, we did it. Yeah, that's why you're going to love this. So here we go. Let's go to the next one. For those of you that have a job, if your boss is giving you a hard time, give them one of these questions. See if you can figure it out. So here we go. You have cosine squared over 1 plus sine theta. Like Chavez, where do I start? As soon as you see something with a square on it, maybe you can use the Valentines formula. We know, what do we know? Cosine squared theta plus sine squared theta, that equals 1. I'm going to move that sine squared dude to the right. So if you move that dude to the right, you get cosine squared equals 1 minus sine squared. This is what I'm going to substitute in the numerator. Does that make sense? So here we go. I'm going to write 1 minus sine squared over 1 plus sine theta. Are we still cool? Okay, so I'll wait for you guys to catch up because I can see some of you guys writing really fast. Now here you go, guys. If you are beast at algebra, you will recognize that the numerator is the difference of squares. In algebra 1 and algebra, I think in algebra 2 you learn about difference of squares, right? So this sine, look, this is just sine theta times sine theta, guys. So because the numerator is just the difference of squares, you can just go 1 plus sine theta, 1 minus sine theta. Look how beautiful that is. And then you just go to the bottom and you just write 1 plus sine theta, and then I see, oh, OMG, there's a factor I can cancel out. What factor can I cancel out? Heck yeah, cancel it out. 1 plus sine theta. What are you left with? There you go, guys. You guys are winning. You guys are winning. You guys should definitely go get canes today. Oh, yeah. I got you, miss. Oh, man, you are winning, miss. All right, here we go. Question 3. Chav, I don't see any, I don't know how to do this one. I'm going to give up. No, don't give up. Look how simple it is, guys. Look how simple it is. None of these answers have a pi or 2 pi embedded, correct? So that means we got to get rid of those 2 pi's there. Now, what do we say? If we do one revolution, are we still in the same location? So this right here is just cosine x. And this one right here is sine x plus 2 pi. That's just going to be what? Sine x. So let's rewrite it. Cosine x over sine x plus sine x over cosine x. I bet you we can get a non-Precal student to answer this question who has never been in Precal before and still figure out what the next step is. Do you want to help us out, miss? Don't worry, you'll be fine. So, what do you think? I have a fraction. Do you remember in 5th grade when you added fractions together, you needed to do something? So, in order to add these 2 fractions, I need a common something. What do I need? Heck yeah, we need a common denominator. Look at that, guys. Common denominator. We got this. See? So on the right-hand side, I'm going to multiply by sine x over sine x. On the left-hand side, I'm going to multiply that dude by what? Cosine x over cosine x. You guys got this. So now this is what you're going to have. Cosine squared x over cosine x sine x plus sine squared x over cosine x sine x. And if you want to do it in one step, that's fine, but I want to show all the steps right now. The denominators are the same. I'm going to put them together. So here we go. Cosine squared x plus sine squared x all over cosine x sine x. Chavez, that's not my answer. I don't see that answer choice in there. Well, guys, have faith. Relax. Look at the numerator. Cosine squared plus sine squared equals 1. Always. Not Juan. Forget Juan. Okay, I'll stop, guys. Maybe, maybe some of you guys have bad experience with Juans. All right, cosine squared plus sine squared equals 1. So 1 over cosine x sine x. And then, yeah, you're probably looking at it like, Chavi, I still don't have the answer. Separate it, guys. Look, 1 over cosine x times 1 over sine x. Well, what's 1 over cosine x? Secant. What's 1 over sine? Cosecant. So there's my answer. Secant x, cosecant x. See, that's not so bad. Look. It's easy, right? It's like a little puzzle. No, miss. Yes, you can do this. You can do this, miss. Stop. So I will admit that this question here, I put this one on purpose. This is the hardest one that you're going to get, something like this. I will admit that these are hard, but it's only hard because you don't have the experience. If you like puzzles, maybe this will be a nice puzzle for you. The first thing I would do, we know nothing about anything special with a cube. So the first thing I would do is I would change that to cosine squared times cosine. So here we go. Secant theta over 1 minus sine theta. Oh, I put parentheses there for a reason. That might be a hint. 1 plus sine theta over cosine squared theta times cosine. So there it is. I haven't done anything, guys. I haven't done anything. Cosine squared times cosine is cosine cubed. Are we okay so far? All right. The next step. There are so many ways to do it. Guys, focus. There are so many ways to do this. But I think the next step, what looks out of the ordinary? I see cosines, I see sines, but that secant doesn't quite fit. Does that make sense to you guys? So remember that secant theta is 1 over cosine theta. Do you guys remember that? So I'm going to rewrite it. I could put 1 over cosine here, but I'm going to put the cosine down here because I want to save steps. 1 over 1 minus sine theta, cosine theta minus 1 plus sine theta over cosine squared theta cosine theta. So catch up to there. Look, I already knew what you were thinking, miss. Before you even said it. Are we okay so far? All right, here's what we're going to do next. You see that cosine squared? Didn't we just replace cosine squared a little while ago with something? What did we replace cosine squared with last time? That's what I'm going to do then. 1 over 1 minus sine theta cosine theta minus 1 plus sine theta over parenthesis 1 minus sine squared theta close cosine theta. So catch up to there. We're almost done, guys. We're almost done. All right, here we go. Here's the magic. So I need your A game real quick, guys. I need everyone's A game. So focus here real quick. So here's where, if you understand this, then you're golden. I have 1 minus sine squared on the bottom. That 1 minus sine squared, remember, that's the difference of squares. So that's the same thing as saying 1 plus sine theta times 1 minus sine theta. I'm not going to expand it. I'm going to leave it like that in red times cosine theta. So that's what you have here. This one just has 1 minus sine theta times cosine theta. So the one on the left is missing one more. Which one is it missing? The 1, not the 1 minus, because it already has it. The 1 plus. Do you guys see that? If you want a common denominator, it's just missing the 1 plus. Cool? So I'm going to multiply just the left term by 1 plus sine theta over 1 plus sine theta. Does that make sense to you guys? When you do that, you're going to have the difference of squares. So here's what you're going to have. And I'm sorry that I'm taking up all that space. I'm going to write it right here, guys. 1 plus sine theta over, I'm going to write it as 1 minus sine squared. I'm going to pretend I already foiled it. Cosine theta minus 1 plus sine theta over 1 minus sine squared theta cosine theta. So catch up to there. We're almost done, guys. Don't worry. Yeah. Notice this term, are they the same? So when you subtract something that's the same, what do you get? 0. Is there an answer choice that says 0? All that for 0. Cool or not cool?